Hello, welcome back. Today we're going to talk about lab number 2, which is on atmospheric composition, layers, and pressure. The atmosphere, so we all know it, we all breathe it. Let's talk about it. So the atmosphere is made up of 3 main elements, nitrogen, oxygen, and argon, and then a couple main molecules such as water vapor, CO2, ozone, and then some other greenhouse gases such as methane. And then nitrogen, oxygen, argon are mostly consistent. You'll find those percentages in your lab book, but water vapor can range from 0 to 4%. So it really depends on the weather, what time of day it is, and that kind of changes the water vapor in the air. So first we're going to use a problem that uses scientific notation. And just as a little review, scientific notation is used when we have to deal with large numbers, such as the mass of the atmosphere. So 5.6 times 10 to the 15th kilograms equals this large number right here. And we don't want to write out 15 zeros all the time. So we just do shorthand, and it's called scientific notation. So I have a question for you guys. What is 50% of the weight of the atmosphere? So that would be 5.6 times 10 to the 15th kilograms times 0.5. So that's the 50%. And then you get 2.8 times 10 to the 15th kilograms. So you just use that to find your answers in problem 1. Air pressure. So air pressure, you can kind of think of air as a liquid. And then we can kind of look at this diagram of the pool. So at the deep end, you're going to have much more water on top of you, and it's going to hurt your ears. But in the shallow end, you're going to have less water that's stacked on top of you, so it won't hurt your ears as much. So you can kind of think of that as the sea level all the way to space is the deep end, and then on top of a mountain to all the way to space is the shallow end of the pool. So this is another image that kind of reinforces that idea that closer to sea level, there's higher air pressure. So some key points are, think of air as a fluid. Higher air pressure occurs at sea level compared to the top of a mountain or even into space. Air pressure is caused by gravity and increases when there's more air molecules squeezing from above. So if you think about it, at sea level, there's going to be way more air molecules on top of you than at the top of a mountain, which has about, well, at top of Everest, there's only 33% of air pressure than compared to sea level. And then sea level always has the most molecules stacked above. So that's why it's going to have the highest air pressure. Next, we're going to talk about layers. So the 4 different layers of the atmosphere have different temperature profiles. So that's what this graph on the right indicates. As you go up through the atmosphere, it doesn't constantly cool. It cools, and then it heats up, then it cools, and then it heats up again. This is kind of counterintuitive, but it makes sense when we think about it. So the different layers have different temperatures. The troposphere has pretty constant decrease in temperature as you go up. It has 80% of the air mass on Earth. It's where the weather occurs, and it also holds greenhouse gases. So as you go farther up in the troposphere, you're losing molecules, the density of the molecules. So you're going to slowly lose temperature. But then as you hit the stratosphere, ozone and other molecules that act as protective shields from cosmic rays, these cosmic rays actually heat up the molecules, and that's why you get an increase in temperature. And then at the stratopause, you get this pretty quick decrease in temperature in the mesosphere, and the mesosphere is where meteors burn up. And then after the mesopause, there's the thermosphere. So this is where cosmic rays really have an effect on the molecules, causing them to heat up and have extremely high temperatures, but the molecules are extremely far apart. So it's basically the start of space. And there's a lot of debate on when space starts and when the atmosphere ends, and that kind of occurs in the thermosphere layer. So that's kind of just an introduction to the atmosphere and atmospheric composition. If you have any questions, please let me know, and I'll try to answer them. Thank you.